Hello. I'm gonna talk about carrier transport phenomena. First, we're gonna talk about degenerate semiconductor. Semiconductor is when too much doping. So too much doping. So semiconductor works like uh, conductor. So degenerate semiconductor not is not general semiconductor. So, this equation is for not non-degenerate semiconductor. And next, drift velocity. Drift velocity equals drift velocity is on mobility times electric field. So, for electron, drift velocity equals minus mu e times e. And for hole, or drift velocity equals mu p times e. So mobility equals q tau over m. Tau is mean free time. So uh, tau when tau is higher, mu is higher too. But when m is higher, mu is lower. So I drift I drift drift I is equals uh n drift I plus p drift I. So I equals v over r and r equals uh, low L over a. So J equals E over low equals uh sigma E. Sigma E. Sigma is conductivity. So I drift this equation equals this equation. J drift equals Jn drift plus Jp drift. So Jn drift and Jp drift is Qn mu n e plus Qp mu p e. And conductivity equals Qn mu n plus Qp mu p. And we're gonna talk about carrier scattering. Carrier scattering is higher when carrier scattering is higher, with drift velocity is lower. So carrier scattering has three types. One, first, ionized impurity scattering. Coulomb scattering when doping is ion doping donor and anti. So electron has attractive force, and hole hole has a reflective uh, force. So uh, and p-type electron has reflect reflective uh, force, and a hole has attractive force. So this is uh this phenomenon is uh scattering. And 2, and second, lattice lattice scattering, and or Phonon scattering. Each atom, many atoms, and lattice, diamond lattice. Each atom vibrates by room temperature. But room temperature is 300 Kelvin. So 300 Kelvin has energy. So and third, a surface roughness scattering. Uh, at semiconductor, uh, silicon, uh, silicon and the dioxide silicon on the silicon. And silicon between silicon and dioxide silicon in imperfect interface. So total time of flight tau tau means free mean free time using harmonic average tau over one over tau equals 1 over tau phonon plus 1 over tau impurity plus 1 over tau roughness. So, tau is proportional to mu. Mu 1 over mu equals 1 over mu phonon plus 1 over mu impurity plus 1 over mu roughness. This is Matheson's rule. And mobility, at uh, mu of function the function of t mu of t diagram mu t diagram at log scale impurity scattering is this line and phonon scattering this line. So mu mu graph is of this red line and high field effect uh velocity is velocity is proportional to electric field but uh and at one point at one point velocity is not proportional to electric field. So uh, velocity uh, is is not higher, is not higher. So this phenomenon is velocity saturation. And we're gonna talk about diffusion current. Diffusion current uh, at semiconductor uh, this this part this part carrier concentration is high, and this se- semiconductor, this part semiconductor 그 carrier concentration is low. So, diffusion is high to low. So, uh, carrier concentration moves to low, high to low. So, this semiconductor has diffusion current. So, diffusion current diffusion equals JN diffusion plus JP diffusion equals Q dN uh d dnx over dx minus Q dp times dpx over dx at d is uh, velocity times length. So D means diffusion coefficient. So uh, we can know uh, d over mu. Mu is mobility. D over mu equals kVt over Q. So this equation is Einstein relation. So at some 300 Kelvin, D equals kVt mu over Q. So mu is proportional to uh, D. And and total current density equals Jn drift plus Jp drift plus Jn diffusion plus Jp diffusion equals Qn un E plus Qp up E plus Qdn times dn over x dn over dx minus Qdp times dp over dx. And we're gonna talk about generation and recombination. And many uh, at balance band, balance band, electron move to conduction band or is generation. But uh, at conduction band, electron move to valence band is recombination. So this is a band to band or generation or recombination. But at semiconductor, extrinsic semiconductor have a donor energy, donor state and acceptor state. So at balance band, el- at balance band, electron moves to donor donor energy donor state and move to at donor state electron moves to conduction band. So this is two-step process. And at generation, at generation, electron absorb energy. So generation is the absorption process. But uh, at recombination, electron emit uh, energy. So recombination is an emission process. At silicon EK diagram, at EK diagram, uh, this electron moves to move two times. One electron generate uh, generate the this state and move to move to lower energy state and two uh, this electron moves to the conduction band the same state and move to and this electron or generation. So this is inefficient. When carrier generated n equals n0 plus delta n and p equals p0 plus delta p because delta n equals delta p. And next, continuity equation. Continuity equation is divergence J equals minus round del P over round del T. So, uh, JP p-type, p-type silicon, at p-type silicon, uh, current, it has current. So JP and JPX is input. Input is JPX and output is JPX plus delta X. So uh, at G is over R, a generation is over recombination, but JPX is lower JPX plus delta X. And G generation is lower recombination on reverse. So round their P over round their T equals minus 1 over Q times round their JP over round their X plus 2 GP minus RP. And for electron, round their N over round their T equals 1 over Q or round their J time around 1 over Q times round their JN round their F plus GM minus RN. And diffusion length and then diffusion length. At p-type, p-type is many have, p-type has many holes. So a minority carrier is electron. So at electron, n equals n0 plus delta n. So this equation, for using this equation, round there n over round there t equals round there n0 over round there t plus round there delta n over round there t. So Rn equals n over tau n and Rp equals a p over tau p. And these equations is this graph. Uh, this this graph is delta and x diagram. So uh, if x is over 0 and g of p equals 0 and electric field is 0. So djn over dx equals d delta n over tau n and jn diffusion equals qdn times dn over dx. So delta nx equals delta n0 e exponential minus x over root dn tau dn times tau n. So root dn jn equals ln. L is diffusion length. So doping is higher. When doping is higher, the diffusion length is lower. And next, we're gonna talk about quasi-Fermi level. At equilibrium, uh, Fermi level is constant. Fermi level is constant, but not at non-equilibrium, uh, Fermi level is not constant. So we use a quasi-Fermi level. This this is a non-equilibrium. Uh, red 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 line is Fermi 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 level at hole, and the blue line is Fermi level at electron. So n equals ni exponential EFN minus EI over KBT, and P equals Ni exponential EI minus EFP over KBT. So uh, EFN, electron Fermi level, equals EI plus KBT and then N over Ni. And Fermi, whole Fermi level is EI minus KBT and then P over Ni. So total current by electron, uh, total current by electron, the Jn is Jn drift plus Jn diffusion. So uh so Qn mu n E plus Qdn times dn over dx, and equals Qn mu d over dx times uh, EFM over Q. So uh, Jn is uh, con sigma n times d over dx times EFN over Q. Or Jp equals sigma p times d over dx times EFP over Q. For no diffusion current, uh, dn over dx equals dp over dx equals 0, equals 0. So Jnx equals sigma e, and jpf equals sigma e. And last, graded doping. Graded doping is at p type uh, this part is uh, high doping and this part is low doping. So uh, this part is high ionized acceptor, and this part is low ionized acceptor. So uh, in this semi in this semiconductor has electric field. So this EK diagram is this. The red line is a Fermi level, and this line is of valence band, and this line is conduction band. So this diagram is equilibrium, and electric field inside this p-type material, and carrier concentration gradient. So uh, this p-type has diffusion current. So Jp equals Jp drift plus Jp diffusion equals 0. So uh, So JP equals QP QP0 mu PE minus QdP times dP0 over dx. So and electric field is proportional to slope of conduction band or balance band. So mu PE equals dP over kT times QE. So uh some more so so dP over mu P equals kBT over Q. This equation is Einstein relation. Thank you.